Hello, my dear students. This is Iklag sir. I am back with one important problem in NLM. Okay, and that is body in equilibrium. Okay, have a look at the problem. This is a block. The mass of this block is given to you, that's equal to root 3 kilogram. Okay, and then it's hanging with the help of this string here. Now, when external force, which is capital F, is applied somewhere here at the midpoint of the string, all right, such that the upper part of the string makes an angle of 30 degree with the vertical. This angle is given to you, that's equal to what? It is equal to 30 degree. Okay, so that's given to you. Now what's the question? The question is this: calculate the tension in the string. Calculate tension in string such that the block is in equilibrium. That's what you are supposed to calculate, and this question has been asked in JEE 2023. So let's try to crack this question. The first thing you will try to do is that you will see how many forces are there at this node, at this 0 point. How many forces are there? There are obviously three forces. Number one is this external force, which is F. Number second is tension in the string. Here in this part of the string there is tension string, which is equal to T. And number second, in the vertically downward direction there is a force which will be obviously equal to the weight of this, that is root 3 into G, which is equal to what? That is 10 root 3 Newton. All right, since in the vertically downward direction there is a force on this block, that is M multiplied by G, which is obviously root 3 into G. So which means that in this string the tension here will be also equal to what? Root 3 G. Okay, now what we are supposed to calculate? We have to calculate the value of this T such that the whole system is in equilibrium. Now how to do that? Let's do one thing, that is resolve this T into the rectangular components. So obviously this T will have two rectangular components, one in the vertically upward direction, another in the horizontal direction. Since this angle is 30 degree, which means that this angle has to be 30 degree. Okay, this T will have two rectangular components, तो ये वाला component इसका आएगा T cos 30 degree and this component will be T sin 30 degree, isn't it? Okay, now what is the net force on this node? That is equal to 0 because it is at rest or it is in equilibrium. When the net force is equal to 0, it simply means that this upward force, which is T cos 30 degree, should be equal to downward force, which is 10 root 3 Newton. From that we can calculate T. If we are supposed to calculate this external force, we can do that as well. Simply this external force will be equal to T sin 30 degree. From that equation we can calculate the value of this capital F. But let's first of all try to calculate the value of this tension in the string. This is T cos 30, this is 10 root 3. Let's equate these two. Okay, so the equation becomes something like this, that is T cos 30 degree equals to 10 under root 3 Newton. All right, now you tell me what is the value of this cos 30? That is root 3 divided by 2 equals to 10 root 3. This root 3 and root 3 cancels, so the answer comes out to be 2 into 10 is 20 Newton. So the tension in the string comes out to be 20 Newton. This is the answer to this problem. Okay, let's try to calculate the value of this F as well. Okay, we are not supposed to calculate the value of F, but if for example question में पूछा जाएगा कि calculate the value of F, so how to calculate that? Simply what I will do is that I will equate F with the T sin 30. That's what I'm going to do. So simply this F is equal to what? It is equal to T sin 30 degree. F we have to calculate. T, its value is 20 and sin 30 आएगा बेटा 1 by 2. 2 and 2 will cancel. F comes out to be 10 Newton. So we have calculated the value of the tension string and we have calculated the external force as well. But the answer to this question is this 20 Newton. I hope that this problem is crystal clear to you. See you next time with one more beautiful problem of NLM.